We want to welcome you to another Theory of Statistics class. Of course, we're starting chapter 3 today. But before we go into that, I promised the other time I was going to walk you through the application of Bayes' theorem in odd form. Particularly, we want to apply this to O.J. Simpson case. But before I go into the case, I first want us to have a recap on Bayes' rule in odd form. Now, when you take a look at what I have here, in statistics, particularly in the court of law, there are two possible values, parameter can take. It's either somebody is innocent or somebody is guilty. So we take a look at theta and a theta complement. So those are the two possible parameters, theta and theta complement. Oh, so that the person is innocent or the person is guilty. So that will come in form of hypothesis. And of course, whether the prosecuting counsel or whatever we present evidence before the court, the evidence here is our data X. Okay, that is the evidence, data that we have. Now, I told you the other time, we have what we call prior hord, likelihood hord, and the posterior hord. When I talk about, I'm going to start from the prior hord. The prior hord, we have something to do with the hypothesis before the court. Okay, when you take a look at the prior hord, the probability of H and divided by the probability of the complement of that. Okay, you are looking at the ratio of the probability that the accused person is innocent, okay, to the probability that he is guilty. That is what you can see in the prior hord. There is nothing like X. There's nothing like data. The prior probability actually means the probability of the state of nature before you collect data, before seeing evidence at all. Somebody was accused of wrongdoing. Okay? Now, the likelihood ratio, take a look at the likelihood. In the likelihood, that is the data. That is where we're going to have the evidence. Take a look at this. This is the probability that evidence is available given that the person is innocent. Evidence is available given that the person is guilty. There is possibility. Evidence can be presented in the court of law, okay? And when evidence are presented, okay, it's either an accused person is guilty or not, even with the evidence, okay? Now, if I combine the prior with the likelihood, we're actually going to have posterior. What you have at the top is what we call posterior. The posterior will enable us to update our prior belief upon seeing evidence, okay? And I want to figure out what is the probability of H given E, that is, what is the probability that the accused is innocent given the evidence? Then the denominator is what is the probability that accused is guilty given the evidence? That's exactly what we mean. Now, I want us to apply this to O.J. Simpson case. Okay? O.J. Simpson was a former American footballer. Okay? And, okay. Yeah, so actually, when he retired from football, he worked with NBC Sports. O.J. Simpson had a wife, and the wife was found murdered around June 12, 1994, in their Los Angeles home. Of course, the LAPD, okay, Los Angeles Police Department arrested O.J. Simpson. And why did they arrest O.J. Simpson? Because the O.J. Simpson has a hard history of domestic violence, and that was why he was arrested. But let me tell you this. The O.J. Simpson lawyer argued, he was trying to belittle the relevance of the fact that when a partner abuse, their partner, there's possibility, the probability that they're going to murder them is very, very small. And he said, look at that, said, stating that only 0.1% of the men who physically abuse their wives actually end up murdering them. When you take a look at the 0.1%, that's very, very small. But that was a wrong statistics used. And what we want to argue today, statistically, using the Bayes theorem in earth form, is actually to argue that the fact that a man abuses his wife, okay, the fact that he has a history of domestic violence should be relevant to the case, because the Simpson Defense Counsel was trying to say that was not relevant. Okay, we now want to prove statistically that is relevant to the case. We're not saying, we are not proving that he's guilty, but we want to prove that the fact that there's history of domestic abuse, okay, and when the partner found murdered, then that is relevant to the case. Now, but for us to do this, we have to go into record, because the defense counsel actually cited statistics, 0.1% of men, okay, that have a history of domestic abuse eventually murder their wife. Now, in 1992, we have a data. 4,936 women were murdered in the United States, of which roughly 1,430 were murdered by their ex-husband or boyfriends. Now, in addition, assuming that a woman who has been murdered by someone other than her husband had a chance of being abused by her husband is equal to 0.05. Okay, and a woman who has been murdered by her husband had a chance of being abused by her husband equals 0.5. Okay, we have this data set. Okay, now the question is, this is the question we want to answer statistically, and I need you to pay attention. Was the fact that O.J. Simpson had previously physically abused his wife irrelevant to the case? Because that was the position of the defense counsel. The defense counsel ignored the fact that somebody was murdered. He was trying to belittle the case. Okay, we now want to see whether that is actually relevant. Now, I need you to pay attention. Now I'm going to solve this problem. We want to answer a practical question coming from a law court. Now, when you want to do this, we need to start by trying to define some events. Okay, I'm going to let G represent the event that the husband is guilty of the murder of his wife. Let me tell you this. The husband could be guilty or not. Does that make sense? So if G represents events that the husband is guilty, then M represents the event that the wife has been murdered. Of course, the wife has been murdered. Somebody has been murdered. That event has taken place. Then he, okay, we want to consider another event, which is the event that the husband has physically abused his wife in the past. These are three major events that need to be put into consideration. Now, we want to get started. Please pay attention. We want to get started. The very first thing we want to figure out, what is the probability that O.J. Simpson is guilty, the probability that O.J. Simpson is guilty, given that somebody has been murdered, that we can only get that from historical data. In historical data, how do I get 143 over 4936? Because historical data told us that. Historical data, take a look at that. In 1992, 4,936 women were murdered in the United States, of which roughly 1,430 were murdered by their husband or ex-husband or boyfriend. We got that statistic from here. We find the ratio. So 1,430 divided by 4,936. Now, that is how we came across 0.29. Okay? Now, if I have a 0.29, okay, using the law of complement, you know, I told you the other time, the last time we met, that if I have the probability, like now, I have probability of G, this is given to be 0.29, okay? Do you know that the probability of G given this plus the probability of G complement given that is going to be equal to 1? You remember I told you the other side, this condition on M, the complement condition on M. So I can figure out, okay, I can figure out this guy, which is going to be the probability of this, which is going to be 1 minus this guy, okay? And right now, it's going to be 1 minus 0.29, that will be 0.71. Now, the 0.71 is telling us the probability that O.J. Simpson is not guilty, given that somebody was murdered. The first one, the probability of G given, and now I'm using the law of complement that is condition on murder. Does that make sense? We are applying now. If you don't understand, I would need you to ask me a question. Now, after this, the next thing that I want to get, what is the probability of evidence given two events as taking place? The probability of evidence, probability of E, given 2 events as taking place. What are the 2 events I'm talking about? Somebody is guilty and somebody has been murdered. And that was given to be 0.5. If you go back here, if you go back to the historical data, okay, it said a woman who has been murdered by her husband had a chance, a woman who has been murdered by her husband, that means the husband is guilty, right? A woman who has been murdered by her husband, had a chance of being abused. Give me 1 second. Of being abused by her husband is equal to 0.5. That was how we got the 0.5. And there's another one that is 0.05 sheer. Okay? Another one that is 0.05. Okay, assuming a woman has been murdered by someone else. If a woman has been murdered by someone else other than the husband, had the chance of being abused, that means in that case, husband is not guilty. And that was why we got this 2. That was why we got this 2 here. Please pay attention. You can see the first one is 0.5. The second one is 0.05. In the first one, the husband is not guilty. That woman probably was murdered. We have history. Somebody that was murdered by somebody else and not the husband. Okay, 0.5 and murder, by the husband is 0.05. Now we have all these statistics. We've collected them, but what do we want to do now? We actually want to use, Bayes' theorem in odd form. Using Bayes' theorem in odd form. Please pay attention. Using Bayes' theorem in odd form, this guy here is a posterior odd. What is this guy saying? The probability, the first one, if you take a look at that guy, means the probability that the husband is guilty, okay, given that the wife has been murdered and there's evidence. The denominator, the probability that husband is not guilty, okay, the wife has been murdered, there is evidence. This guy here is the posterior odd. Okay, now what we're going to be looking for is the numerator. That is what we want to find. The numerator here is we actually want to link the domestic abuse, okay? We want to link the domestic abuse to the case. We want to actually tell the world, the fact that this guy, abused his wife is relevant to the case. Now, this guy here is a posterior head. This guy here is a prior. The prior is going to be based on the historical data. Okay, it's going to be based on the past information. And this is going to be the likelihood hold. Now I need you to pay attention. This guy is a 0.29 that we compute the other time. This guy is 0.71. This guy is a 0.5. This guy is a 0.05. Now, when I compute it, this actually gives 4.08. Now, let me first interpret. If the ratio of guilty and not guilty equal to 1, for instance, if I got a ratio to be 1, that is 50-50, right? When the ratio is greater than 1, please pay attention. When the ratio is greater than 1, when you have a fraction, okay, and you give greater than 1, then it means the numerator is bigger, right? It means the numerator is bigger than the denominator. So which means this guy is going to be bigger than that. That was why you have 4.08. That was why you have the ratio greater than 1. When the odd ratio is greater than 1, then that actually means the numerator has a big value. Does that make sense? As a bigger value. But if I really want to compute the probability, please, I need you to pay attention. If I want to compute the probability, okay, if I want to compute the ratio, this guy, divided by this guy, okay, actually give 4.08. If I want to interpret using the odd, the fact that the odd is greater than 1, then it means this is higher than this, which means the probability that O.J. Simpson was actually guilty, given that somebody was murdered, and the evidence is actually more than the probability that is not. But this is, can we have a way to compute this guy? Yes, we can actually compute that guy. Now, do you know that this guy, okay, divided by, I want to award an extra credit now. Can somebody tell me how I'm going to rewrite this here using the law of complement for extra credit? 1 minus, the top one, send me a message for extra credit. Good job. So this guy will be 1 minus the top one, right, equal 4.08. I can let this guy to be x. I'm actually going to have x over 1 minus s equal to 4.08. Then I'm going to solve for x. You see why you do equation in high school? I'm actually going to solve for x. When you solve for x, your final answer is going to be this guy. This is a very high probability. Don't forget, probability lies between 0 and 1. What is the conclusion here? Okay, the conclusion is that because I have a very huge probability, then we are now telling the defense counsel that, O.J. Simpson had previously physically abused his wife was very relevant to the case. Done. Is there any question here? Any question here? We use statistics. You're studying these statistics because we use statistics to take a decision in a stochastic world. When I say stochastic world, whether in the court of law, whether in the medical field, in the economy, in the environment, and so on like that, we use statistics to take decision. Go ahead.
So earlier, prior didn't have any condition when we first.
Oh, that's a good question. Before, prior was not having a conditional. It's not condition. Now, in this kind of situation, we're going to put condition. And the condition is just that we are just telling the world. I may decide not to write it in condition. I may decide to say probability of G divided by probability of G complement, but I'm putting a condition M telling the world that somebody has been murdered. Does that make sense? Because this is a serious case. So, but in a Bayes theorem, in a conventional Bayes theorem, prior doesn't come with condition. This is a special case. Does that make sense? This is a special case. Okay, I want to move to